The next presenter that we have is Charles Herring. Charles's career in cybersecurity and data research spans 20 years. He started his career while on active duty in the US Navy as a network security officer. Charles served as a product reviewer for InfoWorld Test Center, so I guess has a lot of experience breaking new things before performing 7 years of public sector consulting work. And then from 2012, worked in a consulting security as a consulting security architect at Lancope and Cisco before founding WitFoo in 2016 to research approaches to mature the craft of cybersecurity operations. So today, Charles' talk will be about moving from Elastic to Cassandra. I'm super excited to see this because, sometimes the Venn diagram of those use cases doesn't necessarily overlap, but Cassandra does have some really awesome things that you can actually use to power some of those Elasticsearch workloads. So I'm really excited about seeing what you learned on this journey. And with that, Charles, over to you.
Appreciate it, Ben. Well, yeah, a lot of the research and doing cybersecurity work is figuring out how to deal with all the data. And so we've been through 6 full platforms. And through that painful journey, we've realized that Cassandra is definitely, as Raul pointed out, the last stop on the train track. The product that we work on is called WitFoo Precinct. We deploy it in on-premise with our customers. We deploy it in public cloud, private cloud, a hybrid of those things. We have a number of technological hurdles to get through, including those deployment options, the different disk configurations that they may have, some solid states, some slow stuff. I think some of our customers run on old school 5 1/4 arrays somehow. So I'm going to wait for a new slide by having, there we go. Boom. So basically what we do, we take in a lot of data, we process it, we provide some intelligence around cybersecurity operations, the business, what you can do to protect and respond to cybersecurity issues, which requires us taking in roughly about a petabyte per deployment per day in most of our deployments. The analytics of our platform combined approaches from law enforcement, so how we contextualize and relationalize data the way a detective would do it. We use approaches from natural language processing to understand the data. We also have some business constraints on it needs to work when we turn it on. So we can't turn a whole lot of levers depending on the different deployment pieces. And we need to give SaaS level monitoring, even though we don't have the software running inside of our data center. We can't control that. So it's a lot of things for us to solve for, or as I like to say, a lot of things on the table that we draw a big circle around and say, we need to address those things. So in the earlier versions of our product, Precinct, we built on Elasticsearch, but we ran into some deal-breaking technological problems. It was non-linear in scale, meaning added a node on, we added on n number of nodes, we didn't get n number of scale back. The memory became increasingly difficult for us to manage given the different configurations. IOPS, disk IOPS is, as we've heard a couple of times today, was also a killer. And then index hotspots, or what we call wide partitions. When we looked at Cassandra, some of the out-of-the-box stuff we got that we didn't even realize was we got data center awareness. That was pretty cool. Memory containment and the way that Cassandra works, load balancing from the data ingestion throughout our pipelines. And what ultimately became a problem in Elastic was a bad license, right, with Elastic changing it. So being an Apache Foundation project gives us a lot of confidence that we're not going to run into legal issues supporting our customers down the road. We did decide to lean into Cassandra's way, not try to do Cassandra Elastic, but how would we do something Cassandra's way? How do we make it happy? And so first start with replication factor 3 to give us some flexibility in different consistency form queries and keep the schema simple. Keep it down to a JSON blob, a partition key with a primary key for allowing us to do table scans, partition fetches, or row fetches when we needed them, and be nice to the Merkle trees. A lot of the work that we wanted to do was get into data ingestion, making our decisions as we're receiving the messages. How many rows do we put in each partition? How many, we want to index every row and put that into a different JSON object, and then do all of our analysis before persistence so that we're writing and avoiding wide partition or hotspots in that. As we started moving into Cassandra 4 testing, we found we also did Java 8 to Java 11 testing, which showed us G1 or garbage first collection was really good. It was much better than working with old CMS as far as memory and CPU, and it was pretty painless. The only issues we really had was dealing with key certificates with getting to FIPS compliant encryption and replication across them. There is a blog post, and appreciate you putting that up, Patrick. We did some testing on beta 4, so we'll do RC1 here shortly. But read writes were about the same using our approaches, a little bit faster with Cassandra 4. Repairs were much faster. Garbage 56% faster. Garbage collection was 34% faster, and compaction was 52% faster. So a lot of great improvements in how we're maintaining these petabytes of data coming in each day. So I'm done. There you go. Let's win something. Back to you, Ben.
Thanks so much, Charles. And I'm going to pass it very quickly over to you, Melissa. But hey, can I just say, love seeing those real world 4.0 stats. Like, I absolutely love it. And it's great to see those real world experiences backing up a lot of the benchmarking and a lot of the experiences we've also had internally for my company. So super, super good news. Super excited to see that stuff come up on the screen.